So welcome back. In this video we will talk about tuples and lists, which are very basic and very important data types in Python. Let's start with the tuples. The tuples are basically containers where you can, in ordered way, put in various things of arbitrary type. So for example, as you can see here, I'm defining a tuple with 3 elements, and this tuple contains 3 different type of entries. It contains an integer, it contains a floating point number, and also a string. As you can see, tuples are delimited by parentheses, like here and here, and the individual items are basically separated by commas. What can you do with tuples, or how can you define them? You can leave away those parentheses if you wish, if they are non-ambiguous. So basically you can also define the tuple as you see here. If you want to define an empty tuple, which means a tuple which does not contain any items, then you just make a parenthesis opening and closing this. The thing is a little bit more tricky if you want to define a tuple with a single element, because, okay, you have to put it into parentheses like here. However, Python has to know that these parentheses are not just there in order to have a usual parenthesis as you have in expressions if you want to regulate the order of execution, but you want to really define a tuple, and therefore the convention in Python is that if you want to define a tuple with a single element, then after the element you have to make a comma in order to make sure that yes, this is meant a tuple and not just a simple parenthesis, right? If you have more than one element, then of course it's non-ambiguous anymore. Nevertheless, Python allows that you are adding also here a comma at the end of the last element as well. So basically it's allowed to do that, but when Python prints it, then you won't see it anymore. How can you access the elements of the tuple? This is a little bit similar to that what we have seen for the strings, where we could access the individual characters in the string by using the notation with the square brackets. This is exactly the same here. We can access the elements of the tuple basically by specifying the name of the tuple, the square brackets, and the index of the element. As usual, we are in Python, so therefore we are starting counting from 0, right? So if you want to have the very first element, the 0th element in the Python sense in the tuple, then you are just writing the name of the tuple, the square bracket, and the 0 index. Similar as we did before, you can also access the last elements or elements from backwards by using negative numbers. You can have ranges, as we have seen, the same as by the strings. Here, 1 to 3 means give me the second and the third entry. So basically this is the 0th entry, this is the first entry, this is the second entry, and basically 1 to 3, which means we are starting from 1 and going up to 2. We know that, or up to 3, but we know that the lower index is always inclusive, the upper index is always exclusive in Python, right? And similarly, as we had last time, you can even leave away the range, the starting or the ending point of the range, depending what you want. Then the default values will be used, and you can also specify a step size if you want. So if you want to have a tuple turned around, basically you could do it also this way. It's very important that tuples are immutable data. So basically, once a tuple is created, you cannot create it. So it's not possible to say, take the 0th element of the tuple and replace it with something else. If you try to do that, you will get a type error. Tuples are immutable, so they cannot be changed. However, you can of course create new tuples or tuples with modified content by combining tuples and creating a new object. Similar to the strings, where 2 strings added together, you got the concatenated strings. This is the same for tuples. If you have 2 tuples and you are adding them up, like here t1 plus t2, then you get a tuple which contains the same elements as the 2 tuple had before. So basically you get the 2 tuples appended to each other. Similarly, as we could repeat strings with a multiplication operator, the same multiplication operator is also valid for tuples. If you have here tuple t2 and multiply it by 3, that you will get a tuple which contains the original tuple, the content of the original tuple 3 times, as shown here. If you want to know the number of items in the tuple, that's also very simple. You're just using the len function, similar as we could get the length of the string, the number of characters in the string. We can get the number of items in the tuple using the len function. and the T4, which has 6 elements, would of course return 6. There's a very interesting thing which you should know and which we are using in Python quite often. Is a so-called tuple unpacking. And this tuple unpacking I can demonstrate here. So let's define first a tuple with 1 and 2. And basically, when you want to assign this tuple to a variable, and you know that this tuple contains exactly 2 items, then on the left-hand side of the assignment, you can specify 2 names like T1 and T2 here. And if you execute that, then you will see that T1 will contain the first item and T2 will contain the second item. So this is called tuple unpacking. Basically, the first of the tuple item will assign to the first variable. The second of the tuple item will be assigned to the second variable on the left-hand side. Of course, it only works if the number of arguments or the number of names on the left-hand side matches the number of items on the right-hand side. So if we are trying this one here, where the tuple has 3 elements and we are trying to assign it to 2 names only, then this will not work, because of course there will be too many values to unpack, because you are here only specifying 2 items, but you have 3 items to unpack, then it doesn't work. We will see when we are dealing with lists that even that one can be solved, but in order to be able to introduce that, we will use or need the concept of lists. So let's go to the lists. Lists are basically like tuples. The only difference is that they are mutable, and this is a very, very important difference. So basically, lists, after they have been created, they can be manipulated. There are a syntactical difference between lists and tuple is that lists are basically indicated by square brackets instead of parentheses, but round brackets, and otherwise everything is the same. So you can have different elements of different types, so that they do not have to have the same time. You are separating the elements with commas from each other, and that's basically it. You can exactly the same way index the list as the tuples. So the 0th element would be the very, very first element. The -1 would be the last element. You can just access ranges or even with step size and turn the list and so on and so on. You can get the lengths of the list with the length function. You can create an empty list here with a square opening and closing bracket. For the case of lists, if you want to create a list with 1 variable or 1 item only, then you don't need anything fancy, because it would be because you are using the special notation of square brackets. So in contrast to the tuples, you won't need this extra comma there. But again, similar to the tuples, it always allows to add a comma also after the last element if you wish. You can use the plus operator in order to concatenate lists to each other, so create a new list, which is the concatenation of the previous 2 lists, or the multiplication operator to repeat a list, right? So it's very, very similar to what we have learned about the tuples already. The big differences which the tuples could not do is that you can change the elements, right? So basically, if you here have a look at this list where I'm defining a list with 1, 2, 3, 4 elements, 2 integers, a string, and a floating point number. And then basically, if I just here let Python to give me the content of the list, then you can try it also yourself. You see that you get, of course, the same elements which you put into the list. Now you can say, okay, take the 0th element and please replace it, and so now, which is the 0th element is here. This is basically the number 3, and replace it with the number 42. And then if you do that, execute it, and basically let you show Python what is the content of the list, then you will see that the 0th element had been indeed replaced with a new content. So it was possible after the list had been created to manipulate the content of the list. Of course, you can also change not just single elements, but even ranges in the list. So if you want to change the first 2 elements from 0 to 2 and replace them with 1 and -1, then you can do that without any problems, and you will basically get a new list where the first 2 elements had been replaced. You can even do the same trick with step sizes. So if you want to say, okay, let's go from the 0th element up to the 4th element and replace every second element, and then here you are providing the right amount of elements on the right hand side, then you can see that this has been here rewritten as it should be. If the range is continuous which you're replacing, so you are going from 0 to 3, then it's even possible to provide here on the right hand side a smaller or a longer list, and then basically this range will be cut out from the list and replaced with the one which is on the right hand side. So here in L1, if we are going from element 0 to 2, so we are replacing the first two elements basically with 9, then here you see that it has been basically accordingly replaced. Okay, yeah, that's basically about lists. And you can also delete elements from the list if you wish, using the del operator or the del statement here as written here. So you can say, okay, I want to delete the 0th element of the list, and then you see that the 9, which was before the 0th element of the list, just vanished. Or if you have a longer list and you want to, I don't know, for example, you want here to start with the 0th element to delete every second element, then you can pass also this range to the del statement, and then accordingly list would miss those elements. The list, because they can be modified, they have so-called methods. We didn't talk about methods yet, but at the moment you just should memorize them. That methods are functions which you can manipulate the data of a given object, and basically those methods belong to the object itself and are able to manipulate its data. And the way we write them in Python is that we are writing the name of the object. In our case, this is a list. Then we are writing a dot operator, a dot, and then the name of the function or the method. And if the method needs any parameters, then we are passing these parameters within parentheses. And one of those methods which you can use is the append method. So basically, let's start with an empty list, L5, and then we are just executing as the next line L5.append1. So we are appending the element 1 to the list L5. And if you then let, for example, in Jupyter Lab let Python show you what is the content of the list, you will see that basically it contains a single element 1, so that the element 1 had been, that integer 1 had been appended to the list. We could continue and, for example, here append 2 to the list L5, and then you see, okay, afterwards L5 contains already 2 elements, and then name the integer 2 had been appended to the list. You can also extend the list with the content of another list. This is the extend method. So if you have already the things which you want to append to the list within a list, then it's much easier to use the extend method. So here we have the L5 list, and we extend it by the content of the list, which contains the integers 3, 4, and 5. And if you extend that then to this 1 and 2, which we had before, we will have this new elements, and basically you are ending up here with a list which contains all the 5 elements. There is also an alternative way of doing it, and we will talk a little bit later about that with the so-called infix operators. You can just write L5 plus equal is 5. That means that L5 should be the content of L5 plus this list here, and this would exactly result in the same list as the other one. There are a lot of other methods which can be used to manipulate lists or change the contents of the list. I definitely won't show you them here all because there are numerous. You can just basically look up the Python standard library documentation about sequence types to have a look what is possible. However, one thing which I would like to note, because we will maybe use it in the exercise, is the so-called sort method, where you can basically sort a list. The sort is also an in-place method, which means it manipulates the content of the list. So for example, here, if we're creating a list LL, and then we are then invoking the sort method of the list with the list LL, then basically the content of LL will be changed, and it will be contain the items in a sorted way. If you happen to want to sort in the exactly reverse order, then you have to pass an extra argument to the sort. You can say the keyword reverse is equal true, and then it would make us the sort exactly the other way, the reverse way, as you would expect. There's also another operator which can be used if the list is not too long to check whether some element is present in the list. So the in operator, so let's assume we have this list L5, and now we are just basically checking whether the element 3 is contained in the list. So we are saying 3 in L5, and you see that we get a logical true from Python because the element 5, the integer 5 is present in the list. If you are querying for some other kind of element which is not present in the list, for example here the -1, then you see that we obtain the answer false. Here I would like to mention that you should be very careful with the in operator. It's fine to use it for structures, for lists which are very small. However, if a list is very, very long, then you should not use the in operator to look for items, because the in operator goes through the entire list and checks it element by element. If you have big data sets where you want to check for the presence of a given element, there are much better data structures than lists. So then in that case, you should not use lists, but sets or dictionaries, depending what you do. And we will see examples for that in the next lectures. Also, like tuples, also lists can be unpacked without any problems, and this is very, very similar to how it's done for tuples. So for example, if you have a list with 2 elements with 1 and 2, and then you can unpack it by saying, okay, A and B. So basically, if you have 2 elements, then I'm providing 2 variables. And then after the assignment, the first variable would contain the zeros element, the second variable would contain the first element of the list. What happens, of course, here also the number of elements must match. The left-hand side, the number of items, the number of names you provide should be exactly the same as the number of elements in the list. However, there is a trick you can do, is to use the star operator and to say, okay, I have a list, and then I'm assigning the first element to this name, the second element to this name, and all the rest, whatever is inside the list, should be assigned to the variable rest. And the star means I'm not saying how many items it is. Any items which are still there should be assigned to rest. And then you see that basically A would be the first element, B the second element, and the rest would be always a list. And this list contains the remaining elements of the list, right? You can do the same unpacking actually also with a tuple. So basically, if you had not a list but a tuple, it would also work. But nevertheless, the rest would be always a list which you get at the end. And this unpacking can be, for example, very nicely used for certain functions. One example which we had already is the turtle graphics. And if you, for example, have a coordinate as a tuple or as a list, doesn't matter. So basically with 2 components, and you want to invoke basically the goto function of the turtle, which actually would like to have the x and the y coordinate as separate arguments, like here, then basically you can just write the name of this tuple or this list and write a star in front. And this would basically unpack the coordinates tuple in this case and use it as individual arguments. So basically, whenever a function expects a certain number of arguments, and you have these arguments, the values for these arguments already within a tuple or a list, then you don't have to unpack them one by one by indicating the appropriate indices, but you can just put the star operator in front, and then it will be automatically unpacked. And this is a very neat way to unpack certain containers, tuples, or lists in function calls. There's one thing we have to talk about that which is very important, is the assignment of mutable types. And we have seen the last time for the immutable type, and I already started to emphasize that please keep in mind that if you make an assignment in Python like here, so for example you say L1 is equal this list, then this means 2 operations. First, the list, the right hand side is created in the memory, which in this time the object is a list, and then a name is invented. L1 is created, and this name just points to the object. If you then go and say, okay, I want to introduce a new name, L2 should be equal L1, it only means that there will be an L2, a new name created L2, which will point to the same object in the memory as L1. So there is no new object created, it will just point to the same object as L1 did. Now, if you are making a new assignment for L1, let's say we are assigning L1 with this 3, 4, 5, then what does it do? It basically creates a new item in the memory, a new object in the memory, the list 3, 4, 5, and the name L1 will point from now on to this new object. So basically, if you are using L1 on the L2, you will get the right items. So far, so good. Things are getting a little bit more funny if you try to modify those objects. So let's do the same exercise again. We are creating first a list L1, and then we are saying L2 is equal L1. So basically what we end up is two names, L1 and L2, pointing to the same object. Now you do the following. Now you start to manipulate L1. You list L1 by setting the second element to -1. However, L1 is just a name which points to an object in the memory, and therefore this modification will be carried out on this object in the memory. That means that also L2, which points to the same object, will see these changes. So basically, if you are then giving out the content of L1 or L2, you will see that both of them have been changed. So please be aware that if you make an assignment, this is just basically an aliasing or a pointer. If you are familiar with this concept from other languages, they are just the names and just pointing to an object in memory. And if you say L1 is equal L2, then you get just two names pointing to the same object. So if you're manipulating one of them, also the others will see it. And of course, sometimes it can cause unwanted side effects, which are not that easy to debug. So even if Python behaves in a way strange, you don't expect it, and things start to change, although they are not supposed to be changed, then very often this is exactly what is behind that. So please watch out for that. There's a good reason why Python does that actually, because it's super efficient. Very often, basically, when you are making these assignments, there's no copy made. So if you have a big list, this list would not have just 4 items or 4 billion items. The assignment would be super fast, and you could basically just call or access the list under the two names without any copying. Now, if you want to make a copy, you can request it explicitly. For example, for a list, you can request a copy by explicitly packing it in the list function. So basically, when you say L2 is equal list L1, then Python would go over the items of the first list and make a copy of them and put in a separate list. And then you end up basically completely differently from before with two objects in the memory. Both have similar contents, a list with integers 1, 2, 3, 4. However, they are separate in the memory, and therefore each name points to a different thing in the memory, to a different object in the memory. And now, if you start here, basically to manipulate L1, then you are setting the according element in the list which is pointed by N1. But because L2 points to a different list, it won't be affected. So basically, if you are here giving out L2, you will see the original content. So that's a way to create a copy. And then the two lists are decoupled. However, what you should keep in mind that Python is making on the so-called shallow copies, and I will not go into the very big details, but just demonstrate it why that you should be still careful. I will have a list L1 here and a list L2, and I will create a list L3, which is just nothing else, just a list of lists. So basically, it contains the first element is the list L1, and the second element is a list L2. It's not appended, but it's basically a list of lists. So basically, if you go out give out L3, then you see that the first element of L3 is a list itself, and the second element of L3 is a list itself, right? Okay, so far so good. In order to make sure that I'm decoupling my L3 from the lists L1 and L2, I just made here the call to the list function. So basically L3 was a list of L1 and L2. However, this is not really decoupling. Python makes a so-called shallow copy. That means only the upper layer of the list is copied. So that means I will get a new object here with L1 and L2. However, L1 is just a pointer to the original list L1, and L2 is just a pointer to the original list of L2, because here I was providing pointers, names, right? This is very, very important to note. Why? Because then, if I now start to manipulate some element of L0, so I'm taking the zeroth element of L3, which is basically this list here, and the zeroth element of that list, which is basically the element 1, I'm setting to 9. Then you see that it's indeed happened. Here I have a new list of lists where the first element of the first list, or the zeroth element of the zeroth list, is 9. However, because this was just a symbolic connection to the original list L1, also L1 changed. So even despite the fact that I use the list copying here, because it's a shallow copy, there could be still side effects. So please always keep in mind that even copying is just shallow copying in Python. It may lead to unwanted side effects. If you want to have if you need a real copy, which is warrantedly a copy, and there are no connections between the original and the new object, then there is a deep copy function in the module copy, and then it creates a true nested copy. But most of the time, you don't need that, right? So if you really think about deep copy, then maybe you should do your algorithm differently. Okay. One thing I want to talk about is the in-place operations, which you already actually used. And I just want to make a summary of them. So basically, you can make in-place operations by writing plus equal, or minus equal, or multiply equal, or divided equal, or integer division equal. And this is basically formally equivalent as if you would have written that what is here on the right hand side. So you would say A is equal A plus B. What does it mean? Take A, take B, add them together, and the result should be associated again with the name of A. So the old value of A is lost, and the new result should be associated now with A, and with all the other operations is the same way. The reason why I'm talking about here is because for mutable objects, it makes a difference whether you write long is equal long plus short, when long and short are two lists, where long is a long list and short is a short list, or whether you write long plus equal short. The end result would be the same. However, if you use the in-place operation, Python has the possibility to optimize it. If you use this, the original expression with long plus short, then first there will be a list created long, a list created short, there's a temporary copies created, they are appended, and the result is assigned to long. So basically, if you are unlucky, then the list long had been just doubled, created, and if the list is very long, that could take quite a while. If you write, on the other hand, like here with the in-place operation, so basically long plus equal short, then Python has the possibility to optimize it without making any unnecessary copies. So whenever you have modifiable, mutable objects on the left-hand side, and you want to change their value, then try to use the in-place operations. Of course, if you are using lists, you can also use the extend function call, method call, which we have seen before, and that's warrantedly not making any copy of the list. So otherwise, what I would like to show you here is the containers, how we can iterate over containers, and this is also very similar for that what we have seen for characters and strings already. So basically, if you have a for loop and you are here iterating over a container, then basically you can use a loop variable, and at every iteration in the loop variable will get each element of the list individually one by one. So every iteration of the loop gives the next element under the name item. So that's super easy. Lists are ordered, so you would get exactly the elements in the same order who are in the list. You can also use, so whatever you can iterate about over, you can also use that to initialize or create lists or tuples. So for example, if I have a string test, and the string test is a container and something which we can iterate over. If we iterate over, we get at every iteration, as we have seen last time, every character of the string one by one. And if you just now put it into the list, in the list function, then basically it will iterate over the container, and every iteration, the result of every iteration would be an individual element within the list. So basically you will get a list with each character as a separated element. You can also use that to convert lists to or tuples to lists, or lists to tuples as well. So basically from whatever you can iterate over, you can create a list or a tuple out of it. There's also one interesting thing if you're talking about iterators, which is very often used in Python. It's the so-called enumerate iterator, which just basically takes something iterable, for example, a list or a tuple, and wraps it and creates another iterable object out of it. And you can use that basically to enumerate the objects in the list. So here I had the list here with those 4 elements of 4 different types. And if I just say enumerate and then create a list out of that, then you will see that I get the list where I have the first element of the original list, or the 0th element of the original list, and the number 0 as a tuple. Then I have this first element of the original list and the number 1 as tuple, the second element of the original list and the number 2 as tuple. So basically it is giving you back always tuples. The first element of the tuple is the index and the second element is the corresponding element. And the good thing is you can use that if you have something, a loop where you have to access basically not just elements of the list, but it's also important to know their position. So for example, if I wanted just to have a print out where I'm printing out the sequential number of the elements and the elements themselves, then in the loop I have to access the sequential number as well as the element, and I can do it either this way as here. So basically I can just use the range, I can just here run a for loop over a range of numbers and then write out the numbers which is stored in int and int, so basically the int element of L, or I'm just packing it into the enumerate function and then I am getting back a tuple. As we discussed, the first element of the tuple is the index, the second element is the item itself, and I can use here, as is done here, tuple unpacking to pack those 2 items directly in 2 variables with different names, and then in the print statement I can use those 2 variables accordingly. Okay. And the last thing which I want to show you in this video, and then we finish it, is a so-called list comprehension. And this is something you can create lists from other lists, from other iterable objects, with some filtering if necessary and some transformations is necessary. Why is it good? Because you can create lists in a very compact and very readable way. For example, let's take just an example. We have here a list with words where we have some strings inside, and we would like to now create a new list where we have the same strings as in the old one, but everything lowercase. And for that, we can use exactly this list comprehension syntax. So basically, we have to say what we want to have. We want to have a variable word and just lower it, call the lower function, lower method of the variable, which creates 2 lowercase letters. And what should be this variable word be? This variable word should run over all the items of the list words. So basically I'm saying for word in words. So let the variable word run over all items of words, and then when you have word, just convert it to lowercase. And the results should be enclosed in a list. Therefore the square braces here, right? And then as you can see here, you get exactly that list here. You can also use some filtering. So basically this for you can also extend with an if clause. So you can say, okay, but I'm not including all of the items, but only if the items are fulfilling certain criteria. And the example here is as I have is let's assume we have a list of numbers and we want to have a new list which contains the square of those numbers, but only if those numbers are odd numbers. And then the list comprehension would similar as before. I say that the item num should run over all the items in the list nums. It should square them, but only if the remainder by division of 2 is non-zero, so it's an odd number, and you get exactly that one. And with that, we finished the chapter about lists and tuples.